Hello guys, welcome back to my YouTube channel. Today in this video we will deal with a very interesting topic of DSD, that is the latches. Within the latches we will deal about the types of latches, types of flip-flops. In types of latches we will deal about SR latches and D latches. In flip-flops we will deal about, in upcoming videos we will deal about SR flip-flop, JK flip-flop, T flip-flop and D flip-flops. So mainly in this video we will deal about the SR latches using NOR implementation. There are two types of implementation. One is NOR implementation, other is NAND implementation. In NOR implementation we use the NOR gates for the working of the SR latches, and in the NAND implementation we use the NAND gate for the working of the SR latches. So mainly in this video we will cover the NOR implementation of SR latches. So the question, first of all, the question is, what is the full form of SR latch? The SR latch stands for set reset, means the set value and the reset value. That's why its name is SR latches. In this video we will deal about the logic symbol, logic circuit and the truth table, or we can say the characteristic table of the SR latches. So talking about the logic symbol, we have two inputs R and S, that is reset and set, and it will pass through the SR latch and will give the output. What it will give? It will give the output as Q and Q bar. First remember the first thing, that the output, second output is always complemented. Output is always complemented, means the both are complement of each other. Okay. Now talking about the logic circuit, we have two cross coupled NOR gates. What is two cross coupled NOR gates? We will deal with this. So the cross coupled NOR gates, two means we have two NOR gates, first NOR gate and second NOR gate. The cross coupled means the output of first NOR gate is given to the input of second NOR gates. So this is the reason why this is called cross coupled NOR gate. What is it called? Cross coupled NOR gate. Cross coupled NOR gate. It is called cross coupled NOR gate because it first output is given to the second input. That's why. As we are dealing with the NOR implementation, so we need the NOR truth table, NOR gate truth table for this. NOR gate truth table for this. So in the NOR gate truth table we have two number of inputs. It is two input NOR gate. So if we have two number of inputs, so the possible combination is 2 to the power n. So 2 possible, 2 to the power 2, A and B are, so 4 possible combinations are possible. So that is 0 1 0 0 0 1 1 0 1 1. Now if we do the NOR gate truth table, we know that 0 plus 0 is 0 and its complement is 1. 0 plus 1 is 1, its complement is 0. 0 plus 1 is 1, its complement is 0. 1 plus 1 is 1, its complement is 0. Have you noticed one thing? That one thing is that if any of the input is 1, we are getting 0. Look here, B is 1, again we are getting 0. A is 1, we are getting 0. Both are 1, we are getting. Means if any input is 1, we will get output as 0. Here no input is 1, so we are getting 1. This is the logic, and this we can say as a trick to remember the NOR gate truth table. This fundamental concept we will use in this SR latch for its working. Considering the first case, R is equal to 0 and S is equal to 1, we know that if any of the input is 1, then we will get 0 as our output. So here we can say that one of the input of this NOR gate is 1. So what we will get? We will get 0 as our output. As it is cross coupled NOR gate, so when our R value is 0 and S value is 1, we are getting output Q as 1 and Q bar as 0. Considering the same output, we will take the another case as R is equal to 0 and S is also equal to 0. Now here we have R is equal to 0 and we have this output is equal to 1. We will consider the previous output only to get the result of 0 and 0. So we have 0, we have 1. So 0 and 1, 0 and 1 makes what? 0. So 0 and 1 will make 0, and here also 0 and 0 will make 1. This is same as the previous output, so we will get 1 and 0. When it is 0 0, we will get this. Now the main concept is that if the previous is S is 1 and our Q is 1, we call it as set. As the value for output is not changing, in previous state it is also 1 0, in next step it is also 1 0, we will say no change. Now the third case is R is equal to 1 and S is equal to 0. For this case we know that this is already 1, this is 0. If any of the input is 1, we will get 0 as our output. This 0 will be given here, so 0 and 0 will become what? 1. So if our input is 0, 1 and 0, we will get 0 and 1 as our output as Q and Q bar, and this is called reset. Because our S value is 0 and we are getting Q as also the 0, so we will call it as reset. When the S value is 1 and Q value is 1, we call it set, and when 0 0, we call as reset. So now in the fourth case, if we consider the R value as 1 and S value as 1, we will get, like, if any of the input of the NOR gate is 1, we will get 0 as our output. This trick is always valid. So if R and S is 1 1, what we will get? 0 and 0 here. Here, as we know that the outputs are always complemented, but here the output is not complemented. It means that this is invalid output or invalid state. So for SR latches we need to remember two things. First thing is that for NOR gate, if any of the input is 1, we get output as 0, and we need to remember that if S is 1, Q as 1, then we call it as set for SR latches. If S is 0, Q is 0, we call it as reset, and if here the inputs are not complemented, we send it as invalid state, and these outputs are not changing, so we say no change. That's it for SR latches. These are the very important concept for the future videos, so keep it in your mind. Now we will see SR latches using NAND gate implementation. It is fully same as the NOR implementation, only the difference is in the logic diagram. Here we use two coupled NAND gates, cross coupled NAND gates, and here we use the truth table for NAND gate. Here we can see one pattern here, that if any of the input of the NAND gate is 0, we will get 1 as our output. This we will consider for the characteristic table design and for the working of the SR latch using NAND implementation. So we will take our first case, S is equal to 1 and R is equal to 0. When we take S is equal to 1 and R is equal to 0, what we can see, we can know by the working of the NAND gate that if any of the input is 0, we will get 1 as our output. So this output will be going to the input of this NAND gate. So here it will become 1 and 1, and the output when 1 and 1, it will become 0. So when it is S is 1, R is 0, we are getting 0 and 1 as our output. So 0 and 1. This type of case, when S is 1 and R is 0, we say for SR latch using NAND gate, we say it as reset. Now when we will consider the second case, that S is equal to 0, R is equal to 0, we know that if any input of the NAND gate is 0, we will get 1 as our output. So without taking our mind in this, we will directly write when 0 0 is there, 1 1 we are getting. As we know that the outputs are always complement of each other, so this is our invalid output or invalid state. Now when we consider the third case as 0 and 1, we know that by the working of the NAND gate, if any of the input is 0, we will get 1 as our output. So here we will get 1 as our output, and this 1 will be going here, and 1 will become 0, so it will become 1 and 0 in our third state. Such type of combination will form a set. Now for the last case, when we take 1 and 1 as the input, 1 and 1 as the input, and considering the previous output as 0 and 1, this will become 1, and 1 and 1 will form 0. What it will form? 0. And here the previous output will come here, and the 0 and 1 will form 1. So if we consider 1 and 1, we are getting 1 and 0. So in the previous output we are getting 1 and 0, this output we are also getting 1 and 0. So this case is called no change, because the previous output is same as this output, so we called as not change. So we need to remember the NAND gate truth table and the logic that if any of the input is 0, we will get 1, and when we will implement this, we can easily get this. So this is the end of this video. Thank you for watching the video, and subscribe to our channel Campus Explained. Campus Explained. Thank you.